we're starting to see the investigation of the integration of sensing and communications, and potentially the use of ambient power, that is all the RF energy that is in the air, being used to power wireless devices for 5G systems. Those are just some of the things that we're going to see. Oh, I just lost it when hitting the recording. There we go. Okay. So what are some of the drivers for a 6G? You know, it's all about the applications. Yes, there's money to be made in 6G, but as with almost all of the cellular standards, the real money is to be made with the applications. And we're looking at new applications for 6G, grid control. If we can drive down the latency of the system even further, we can start managing our grid using wireless connectivity. Imagine, for instance, having the capability of turning off the power if a power line drops off of a power pole onto the ground, being able to turn off the power before that electricity will start a fire. If we had that a couple of years ago, we wouldn't have had the mass fires in California. Vehicular communications, car-to-car communications are CV to X, cellular, vehicle to X, meaning anything. So, car to vehicle, car to pedestrian, car to infrastructure communications. In fact, one of the things we've been looking at Virginia Tech is, can we use 5G to get rid of stop signs? Just have an RF link stop the car. Digital twinning, and this has become very hot right now. When you have complex systems, can you essentially be running a simulation, emulation in parallel, and maybe even a little bit faster than real time, so that you know how to adjust the system by looking at what happens with this digital twin? That's going to need very fast communications in order to be able to support that. And then sensing and communications, for instance, collaborative vehicle radar. Will the radars in these automobiles be able to communicate with each other, for instance? Will you be able to use your RF signals to be able to explore what the environment is around, such as the propagation characteristics, by examining your RF signals, or perhaps using a camera to understand what the layout is in the environment, and then be able to do propagation prediction and incorporate that into your radio resource planning. These are some of the things that are envisioned for 6G systems. And of course, fixing 5G. There's a lot of times in which the cellular standards don't just quite get there. For instance, in 3G, we actually saw the introduction of MIMO, but it really didn't take hold until 4G systems. So there will be things that 5G will not obtain, but we'll be able to obtain when 6G comes around. Well, what will it look like? Well, one of the things that I think that 6G is going to look like is a lot like ORAN, actually. We're learning a lot of lessons from ORAN in terms of disaggregation of the network, using this disaggregated network to create a more competitive ecosystem where you don't just get all of your supplier from one manufacturer like a Huawei or an Ericsson or a Nokia, but you can piece it together from different vendors maybe that are small companies, and put it together and have a very sophisticated system and be able to incorporate innovation into that network much more quickly. If you have to replace the overall system, or if you have to wait for a large company, that could slow down the adoption of new technologies. One of the things that I love about ORAN is that our students can implement their algorithms with ORAN. You know, we've been implementing different types of schedulers, performance monitoring, geolocation algorithms using XApps, which you'll learn about in this class. So instead of just doing MATLAB simulations for student research, actually get some hands-on, let's build it and try it out capability. And that's going to have major ramifications on industry, because what it's going to do is short circuit the time that it takes to get from university research into actual product by being able to do that. So I think 5G or 6G will adopt some of those principles of ORAN that will allow for more rapid technology innovation. We'll also see the integration of aerial and terrestrial and satellite components, virtual spectrum, where we have both spectrum sharing, more like a commons of spectrum, along with network sharing, being able to have different service providers leverage the same infrastructure. That gives you the ultimate flexibility, and flexibility is what it takes to have the best spectral efficiency possible. We'll see terahertz systems, although I'm somewhat skeptical of its applicability on a wide scale to 6G systems. When you get such high frequencies, the radio tends to act like light and can be easily blocked. It's also very difficult to generate terahertz signals. Nevertheless, terahertz can support many gigabits per second, tens, maybe even hundreds of gigabits per second, because of the high frequency of that signal. And we will find applications. One of the problems that we will be facing when we go to more sophisticated applications will be bandwidth. For instance, to do holographic transmission is going to require somewhere around 50 to 100 times more data rate than what we have today. And how are we going to support that? Well, we have to go higher in frequency to be able to support that. Frozen. There we go. So we will see, 5G advance and 6G adopted by governments, consumers, and industry, and there will be various advantages for those. I'm going to just skip through some of these. Digital twinning we talked about earlier, and how it's going to have an impact on industry. Autonomous vehicle monitoring, training with fast VR and augmented reality. Augmented reality has a lot of potential to change the way that we educate and train people, to give people some complex visualizations to understand concepts. And for the consumer will see 5G and 6G everywhere, very low power devices, so it gets embedded in your product. You're going to throw your product away for 10 years anyway. You're not going to have to change the battery. The 5G or the 6G system will be embedded in your product. Probably won't even be able to change the battery on it, but it'll always be there. So, just to kind of summarize this, we do see that there are some weaknesses in the 5G and 6G standard that will need to be addressed with 6G. 5G is the ultimate in flexibility. It still has a long ways to go, though, to reach its full potential. We're going to be seeing innovations in 5G, even up to the introduction of 6G. We're going to be seeing all sorts of new applications, exercising new properties of 5G. I don't really expect 6G to be a complete reworking of the network. Networks change relatively slowly. The network that we had for 4G was there for a long time. And the network for 5G, the 5G core, is going to be around for a long time to come. Cost is going to be a driver, particularly for service providers. That is really going to be the key to get them to adopt 6G technology. And DoD is going to adopt to 5G and 6G. They have no alternative. They do not have the money that Apple has or that Huawei has in terms of designing new communication systems. They have to leverage the commercial infrastructure. So, and a couple of good quotes here as I give you my prophecy. Prediction is very difficult, especially if it's about the future. Niels Bohr. But we do have a couple of minutes. Are there any questions that people have about what the future may hold? Yes, Dr. Tripathi.
What is your favorite 6G application, your dream application?
Oh, my favorite. You know, I think making augmented and virtual reality less cumbersome is my favorite application right now for
something like
for
metaverse
6G.
Type reality, metaverse type.
Yeah, it's sort of like metaverse reality, but also a blending of the real world with a virtual world. And you know, I've experienced those systems now with 5G, but they're still pretty crude. They let you know what the potential is, but they need to be more refined.
There is one question on Zoom.
Yes.
What are the main weaknesses you see in 5G standards?
You know, the potential of 5G hasn't been exercised completely yet. So the real weaknesses, I think it's even too early to say what the weaknesses will be until we try to exercise all of the modes of 5G. What is a big question mark in my mind right now is the massive machine-to-machine communications capability of 5G. How well will we be able to support 1 million devices in a square kilometer, which is the goal? It seems like a tall order. We have yet to see it. Yes.
So commercial adaptation, standards said 1 million things in the standards. Commercial adaptation is maybe significantly less than that. So what do you think going with 6G would be the highest candidates for being replaced?
For what being replaced?
From the 5G standard.
Oh, I see. Okay. So the question was, what are the candidates in terms of things being replaced in 5G to come up with the 6G standard? There will probably need to be some changes done at the physical layer and the MAC layer in order to reduce the latency even further. So I think that's going to be essential. I think a disaggregation of the network in a way that would allow us to get a closer control and monitoring of the physical layer is going to be necessary as well, particularly as we go to more of a cognitive radio, AI-driven physical layer.
Yeah, a couple of other questions on Zoom. What do you think about the impact of ORAN in 6G?
The impact of ORAN. I think ORAN is going to be great to show us the way for 6G, the disaggregation of the network. You know, as we try to implement ORAN, we are running across issues with ORAN, latency issues in particular. And I think once ORAN sort of figures that out, then 6G will be able to leverage ORAN to help create an overall lower latency system.
Just one question.
So with the ultra low latency goal of the 6G, are we going to reach a point where the network is faster than the software stack? And then we need predefined operating systems because now the latency is too low in the network and the bottleneck is actually the software?
That's a good question. I just don't know. I do not know. But it is a good question to ask.
I guess we give a round of applause for answering that.
Thank you.